Okay, this lesson is all about recognizing opposite factors and knowing what to do with it. Um, Basically, whenever you see a polynomial or an expression that appears to be in opposite order, like 5 minus x, 6 minus 2y, 6 plus x minus x squared, there's a method which I call the negative 1 method, where if you factor out the negative 1, you can actually reverse the order. So to get warmed up with that, I wanted to show you the opposite of that situation, which is instead of factoring out negative 1, we're going to distribute negative 1. So let's go ahead and distribute negative 1 over this binomial and this trinomial here. So we distribute and we get negative 5 plus x. We reorder having highest power first, x minus 5. Over here, this becomes negative 6 plus 2y, giving us 2y minus 6. And finally, negative 6 minus x plus x squared can be rewritten as x squared minus x minus 6. So let's jump in and take a look. Number 4, simplify each expression. So we're going to start off as we normally do and factor first. So we're going to factor 4 minus 2x. I'll factor out the 2, that's greatest common factor, 2 times 2 minus x over top of x minus 2 times x minus 2. So as you can see, it's very tempting. We want to cancel out the x minus 2 with this term up here. However, they are not identical terms because the 2 is positive, here it's negative, and the x is negative, but here it's positive. How can we fix this? We can factor out the negative 1, which I call the negative 1 method. So if we factor out the negative 1, it ends up appearing right here in the front. So we factor out a negative 1, this becomes positive 2 becomes negative 2, and the negative x becomes positive x, giving us the matching factors so we can cancel out. If you want to take it a step further, let's reorder the negative 2 plus x, so we have x minus 2, and now we can see that they cancel out. What happens to the negative 1? Well, it basically gets absorbed back into the problem, into the expression. So negative 1 times 2 is negative 2 over x minus 2. This negative sign could, could float up to the numerator. It could stay down here at the same level as the fraction bar. Okay, so why don't you try number 5? In this example, we see we have a perfect difference of perfect squares, so we factor. And the denominator looks like it's in opposite order because this is an opposite factor. The 8 is positive, here it's negative, and here the x is negative, but here it's positive. So what do? We factor out the negative 1. So this basically negates the denominator, so we get negative 8 plus x, which we can reorder as x minus 8. So now we can cancel both of these terms out, and we are left with x plus 8 over negative 1, and that negative 1 gets reabsorbed back into the expression. X divided by negative 1 is negative x, and 8 divided by negative 1 is negative 8. Number 6. So here we have another difference of perfect squares. So we have b plus 10, b minus 10. The denominator is a trinomial, so we'll factor this b plus 10, b minus 4. And here we notice the 10 minus b, it doesn't quite match the b minus 10. Again, they are opposite factors, so we have to extract the negative 1, and we end up with our desired binomial here, so it's negative 1 times negative 10 plus b. Let's reorder this, so it's b minus 10, and now we have a match. We can go through, cancel this, cancel this, cancel b plus 10, b plus 10, and we have our final expression is negative 4 over b minus 4, or you could see it as the entire fraction is negative 4 over b minus 4. Okay. Number 7, last example. Again, difference of perfect squares. 6 minus x, 6 plus x. The trinomial factoring is pretty simple. X plus 2, x plus 6. Here we factor greatest common factor of x. Notice that this is a division problem, so we did a keep, change, flip. So x minus 2 is now in the numerator, and x times parentheses x minus 6 is in the denominator. So I want this x minus 6 to cancel with this 6 minus x, so I need to extract the -1, giving me the desired order. This is really x minus 6, so we can cancel these out. We can cancel these out because addition is commutative. It doesn't matter what order it's in. And finally, we are left with x minus 2 over x plus 2, but we still have this negative sign over here, so we see how it's expressed as a negative fraction of x minus 2 over x times x plus 2, or we can float the negative sign up to the numerator, negative quantity x minus 2 over x times x plus 2. We rarely see the negative sink down into the denominator. It usually floats up to the fraction bar or the numerator. And there you have it. That's the lesson, the -1 method. Good luck to you.